Welcome back to the Deep Dive. Today we're plunging into something that might sound a bit technical, but it really affects almost everything you do online.
Yeah.
We're talking about rate limiting and throttling in Spring Boot. Our mission today, cut through the jargon. We want to really get to the heart of what these are, why they're so crucial for reliable apps, and how they actually work, especially in Spring Boot. Think of it like traffic control for the internet. It's working behind the scenes all the time, and even if you're not coding apps yourself, these things are shaping your experience, from shopping sites during sales to just watching videos smoothly.
Absolutely. And they're not just like abstract tech terms. They're real solutions to very common problems in software development. It's all about managing demand, really, making sure things run smoothly and fairly for everyone involved. Keeps the lights on, so to speak.
Okay, let's unpack this then. For everyone listening, let's start right at the beginning. What exactly are rate limiting and throttling? What's the difference?
Okay, so at their core, they're both ways to control how many requests an application handles. Imagine you're at a busy fair, right? Rate limiting is like saying, okay, only 100 people can get on this ride per hour, full stop.
Uh-huh.
In tech terms, that might be 100 API calls per minute per user. If you try to make call 101 in that minute, nope. You get blocked, or maybe told to wait until the next minute starts. It's a hard cap.
A hard cap, got it. So you hit the limit, you're out until the time resets. What about throttling then?
Throttling is a bit different. It's more like the ride operator slowing down how quickly they let people through the gate when a big crowd shows up. Instead of blocking you outright, it just slows down the processing of requests. Maybe your requests get put in a queue or they're handled more slowly. The idea is to manage the flow, smooth out the peaks, rather than just slamming the door shut. Often you actually use them together.
Okay, so throttling is maybe a bit gentler, kind of smoothing things out, while rate limiting is the firm boundary. That makes sense. Where do we usually see these in action?
Oh, pretty much everywhere online. Any web app, API, or system dealing with lots of users or potential spikes in traffic. Think about a big product launch on an e-commerce site, massive rush to check out. That site might use rate limiting on the payment step to stop the payment system getting totally swamped. Maybe limit each user to one checkout attempt every few seconds. Or think about public APIs like weather data or stock prices. They almost always have rate limits.
Why? To keep it fair.
Exactly, to ensure fair usage. So one developer building a bot doesn't just hammer the API constantly and slow it down for everyone else. It protects the resource for all users.
Okay, we know what they are, where they're used, but let's dig into the why. Here's where it gets really interesting. Why are these techniques so important, especially if you're, say, a new developer? Seems like extra work.
That's a great question. And yeah, it might seem like extra complexity at first, but the payoff is huge. It solves some really fundamental problems. First off, and this is critical, they keep your apps stable. Imagine launching something and it goes viral. Thousands of requests hit your server all at once, without limits. Crash, boom, game over. Rate limiting prevents that overload.
Right, prevents the dreaded crash. What else?
Second, they protect your resources and, importantly, can lower your costs. Every request uses CPU, memory, maybe talks to a database or a third-party service you pay for. Letting requests run wild can burn through resources, crash databases, and, especially in the cloud, rack up huge bills. Limiting usage keeps things efficient and affordable.
Okay, stability and cost saving. Makes sense.
Third, as we touched on, they ensure fair usage. You don't want one power user or a badly behaved script hogging everything. Limits make sure everyone gets a fair slice of the pie.
Fair enough. What about security?
Huge. That's the fourth point. Enhancing security. Rate limiting is a frontline defense against common attacks. Think denial of service, DOS attacks, where someone just floods your app with requests to take it down. Or brute force login attempts trying thousands of passwords. Limiting requests per IP address or per user account helps block that kind of abuse.
So it's a security feature too. Interesting. And the fifth?
And fifth, it all adds up to making your apps more reliable and just providing a better user experience. Consistent performance, fewer errors, less waiting. Even throttling, by slowing things down instead of just blocking, can feel smoother to the user than getting constant error messages.
So what this really means for you listening, whether you build apps or just use them, is that these techniques are working silently to make the internet, well, work. More stable, more secure, fairer. Okay, so for the developers listening, how does this actually happen? How do you implement this stuff in Spring Boot? Let's get into the mechanics a bit.
Sure, it's actually quite manageable in the Spring Boot world, thanks to some great tools. It boils down to a few key steps. First, you've got to set the request limits. Define the rules. Like, this specific API endpoint gets 50 calls per second per user, or maybe only 10 login attempts per hour from one IP address.
Hmm.
You usually set these rules up in your application's configuration or sometimes directly in the code using annotations.
Okay, you define the rules. Then what? How does it know who's making the request and how many they've made?
That's step 2, tracking the requests. The system needs to monitor incoming requests and count them against the limits you set. It identifies the requester usually by maybe an API key they send or their logged in user ID or sometimes just their IP address, and it needs to store this count somewhere.
Store it where? Just in memory.
It can be in memory for simple cases, but if your app runs on multiple servers, which is common, you need something shared. And that's where step 3 comes in, often using caching tools like Redis. Redis is super fast. It's an in-memory data store that all your application servers can talk to. It acts like a shared counter. So no matter which server instance gets the request, it checks the central Redis count for that user or IP. This keeps the limits consistent across your whole application.
Like a shared logbook everyone checks.
Yeah.
Makes sense.
Yeah.
What happens when someone hits the limit then?
That's step 4, enforcing the limits. Once the counter in Redis or wherever it's stored shows the limit is reached, the system takes action. If it's rate limiting, it typically blocks the request, often sending back that HTTP 429 too many requests error, like the bouncer saying nope. If it's throttling, it might slow down processing or queue the request.
Okay, and you mentioned sometimes this happens even before the request hits the main app.
Exactly. That's the 5th piece, especially for bigger systems. Integrating with load balancers or API gateways. Tools like Spring Cloud Gateway, which is part of the Spring ecosystem, or services from cloud providers like AWS or Google Cloud can apply these rate limits at the edge. It's like having security at the main entrance to the theme park, not just at each ride. It checks requests before they even reach your application code, which is very efficient.
That paints a really clear picture of the mechanics. Now, this raises an important question. What real-world challenges do these methods tackle, especially for developers maybe just starting out?
Oh, they solve some very common, very real headaches, stuff you will run into. First, the big one, app overload from just too many requests. Your app works fine normally, but a sudden boost of traffic, maybe from a marketing campaign, just swamps it. Rate limiting is the direct solution. It puts a cap on things, prevents the server from melting down.
Right, avoids the meltdown. What else?
Second, related but slightly different, crashes during sudden traffic spikes. Think viral moments, flash sales, unpredictable bursts. Here, throttling can be really useful. It smooths out that spike, processes requests at a manageable pace, preventing the system from falling over. Rate limiting catches the really excessive stuff.
Okay, handles those sudden floods. You also mentioned costs.
Yes, third problem, high resource costs. If your app gets hammered, even if it doesn't crash, it uses more CPU, more memory, more database connections. In the cloud, that equals money, potentially a lot of money. Rate limiting directly controls resource consumption, saving you cash.
Always good to save cash. What about fairness?
That's the 4th problem. Unfair usage by some users. You might have one user, or maybe a bot, scraping your site or hitting an API way too hard. This can degrade the experience for everyone else. Rate limiting ensures everyone plays by the same rules, gets fair access.
Prevents resource hogs. And the last one ties back to security.
Exactly. 5th problem, security risks from attacks. We talked about DOS attacks trying to overwhelm your service or brute force password guessing. Rate limiting is a fundamental defense. Limit login attempts per IP, limit requests to sensitive endpoints. It makes these attacks much harder to pull off.
It really sounds like these aren't just optional features, but pretty essential for anything serious. So for a beginner, someone listening who wants to implement this in Spring Boot, how hard is it? Is the learning curve steep?
Actually, it's surprisingly accessible, especially with Spring Boot. The ecosystem makes it quite beginner-friendly. Step 1 is usually just adding a rate-limiting library. You add a dependency to your project, like Bucket4j or Resilience4j. These are popular, well-documented libraries. Think of it like adding a pre-built module.
Okay, add a library.
Then you set up the rules for your limits. Often this is done with simple annotations right on your controller methods in Spring Boot, like at rate limit above the function you want to protect. You specify the limit, the time window, and the library handles the rest.
That does sound straightforward. What about the shared counting part? Redis.
Right. Step 3. If you need distributed limiting across multiple servers, you use a cache for tracking. You configure Spring Boot to use Redis. Spring Boot has great Redis support, so it's mostly configuration, telling it where your Redis server is. The rate limiting library then uses Redis automatically.
Okay. And the gateway approach.
That's step 4, maybe for more advanced setups. Integrate with Spring Cloud Gateway. If you're already using it, you can configure rate limiting rules right there at the gateway level. This applies limits consistently before requests even hit your backend services. It's very powerful for microservice architectures.
And finally, the cloud.
Yeah, step 5, deploy with cloud support. If you're on AWS, Google Cloud, Azure, they often have built-in rate limiting features at the load balancer or API gateway level that you can just turn on and configure.
So it sounds like you can start simple and scale up the approach. That's good. Are there any key things people should watch out for? Common pitfalls.
Good question. Yes, a few things. First, test your limits carefully. Don't set them so low that you block legitimate users. That's super frustrating. Test in a realistic environment. Second, provide clear messages. When you do block or throttle someone, give them a helpful error message like, "Too many requests, please try again in a minute," not just a generic error. And third, maybe start simple. For a small project, just using an in-app library might be enough. You don't always need Redis or a gateway right away. Add complexity as needed.
Great advice. Test, communicate, and don't overcomplicate it early on. Okay, so let's try and wrap this up. The key takeaway here seems to be that rate limiting and throttling aren't just buzzwords. They're really practical, essential tools. They help you build apps that are stable, secure, fair, and can handle the unpredictable nature of internet traffic gracefully.
Absolutely, and understanding them, even at a high level, helps everyone appreciate what goes into making the digital services we rely on actually work smoothly. They really are the unsung heroes keeping things running, especially when things get busy online. The silent guardians, you could say.
I like that. Silent guardians. Okay, here's a final thought for you to ponder after this deep dive. Beyond software, where else in your everyday life do you notice things that act like rate limits or throttling, mechanisms managing resources or flow, maybe without you even realizing it? Think about that. We'll leave you with that question. Thanks so much for joining us on the deep dive today.
Thanks for listening.
We hope you found this useful, and we'll catch you on the next one.